Hello everybody, welcome to the EDGECAM Probing and Inspection webinar. My name is Miguel Johan. I am the Market and Product Manager for Hexagon Production Software. I'm joined today with my dear colleague Zoltan Tomoga. He is the Partner Support Engineer for the UK and he's going to be driving the technical side of the presentation today.
Hi everyone.
Hey Zoltan. So for the agenda, we're going to be talking about probing versus inspection, separating and making the clear difference of what they mean, how they complement each other. We're going to be talking about the capabilities of the system through feature cycles, how to do reporting, how to run some macros. Then Zoltan is going to be doing a demo on it. Then I take the word back at the end, talk a little bit about licensing, and we close up with a session for questions and answers where we really hope to have a good participation from all of you. So without further ado, I would like to pass the word to Zoltan. It's with you, Zoltan.
Thank you, Miguel. Let's start with probing versus inspection. What is machine tool probing? When I talk about machine tool probing, I usually refer on the controller's CAN cycles, so Heidenhain, Siemens probing cycles, or the third-party installed Renishaw, Bloom, or MNH macros. Most of customers using these cycles to update the work datum on a stock or on a fixture, or update the tool length or a diameter based on a measured feature. EDGECAM support these cycles from 12.5 version. But those cycles were limited only for wireframe, and the new inspection cycles, because they are based on the inspection features, it's much easier to create the features and select directly from the solid. What is EDGECAM inspection? EDGECAM inspection allows you to use a 3D touch probe on your CNC machine to measure any surface points and common inspection features and constructed features created directly from a 3D solid model or by a manual input. So basically the workflow in EDGECAM, you open the 3D solid, you create inspection features directly from the solid, you create the toolpath using the new inspection cycle, you define the calibration method, the feeds, rapid position feed, touch feeds, and then once your cycle created and simulated and saved, you generate the NC code, run on the machine. The machine will use the NC code to generate a result file, basically with your X, Y, Z and rotary axis positions of the touches, and then you copy back that file into your PC and then ask EDGECAM to generate the report. Let's look at capabilities. Most of the machine tool probing cycles are limited. You are only able to create a 4-pointed cylinder or a 3-pointed arc. EDGECAM probing cycles are looking into the selected feature. If you select the wrong feature, it gives you an error. If you select the right feature, it will generate the toolpath. The new EDGECAM probing cycles gives you an opportunity to do less manual input. You can customize the dialog boxes. You are able to save your own masks. And because of that, you can support the Siemens and Heidenhain cycles as well. With EDGECAM inspection, you are able to create the features directly from the 3D solid model, or you can give it a manual input. You can build the constructed features, and what is important, you are able to simulate and collision check your toolpath. In the code wizard, we have a dedicated area for the inspection, and you are able to customize the report. Just a couple of words about installation. For machine tool probing, you have to update your template in the code wizard. Then you have to customize the dedicated area for the different cycles, and then you are good to go. For inspection, you can choose via installing your own macros onto the controller, or you can update the dedicated area to use the third-party macros. So for example, I had a customer where I used the Renishaw positions, the Renishaw touch moves, and then I try to solve everything with the already installed macros on the controller. And what you need is just update the post-processor how to create the result file using a write function or using a dprint function. And now let's do a product demonstration. So open a basic 3D solid model, and I'm going to start from designer so I can show you a bit of a workflow working from designer to EDGECAM and then finally using NCMO to simulate toolpaths. So remember latest version, designer, couple of new functionalities about analyzation, basically similar than what you have in Work Explore for draft analysis or curvature. And let's create a boundary box, because if I create a solid boundary box, I'm going to use this later as a stock inside EDGECAM, but it's much easier for me to create the inspection feature. Send to cam, it's going to open 2021.0. Don't forget to install the latest service updates. Alright, we are in EDGECAM now. Click on fixture database and we are going to select basic wise. Select this one. Then once we have to select now the do-sum machine. So this do-sum machine have an 828 Siemens controller with a Renishaw inspection plus already installed on the controller. Create a features, so we have these inspection features, single point and two width feature. That's going to be perfect for updating the datum. Don't forget, you are easy to edit these type of features. There is one dimension grayed out because that's the surface dimension, and the other two is free to modify, or if it's a circle, the third one. Alright, just change the name and the position. Okay. Alright, so after that, basically, once you have the feature, you just have to select them as a stock. But let's select first a touch probe. Yeah, so touch underscore probe. This is the name of the probe on the machine. Remember, it's a Siemens, so I have to call tn equal code and then touch probe. So these are the new cycles: point, circle, plane. Let's create first a probe point to update the Z0 on the top basic. So depends on the controller, you might not able to change the move feed or the protected move feed, but if I select print, this post-processor will generate an R23 equal 1. That means the Renishaw cycle will print in a basic Renishaw report. So define the width. I'm gonna use the update workup set G55, print out. Remember association. So toolpaths can be associated to the datum or to the feature. Create the other toolpath and then move to tool change. EDGECAM probing cycle, full simulation. So only the second touch is not simulated in the simulator, but that's based on your controller. Do you do 2 touches when you probe something, or you do only 1 touches? That's really up to you, but in the end of the day, this toolpath will be collision free. So generate a quick NC code. Let's see how does it look like. You can see L9800 variable reset 32 probe on, and then we have the cycles, and this is a Renishaw installed on a Siemens, so I'm using R variables and the subprogram L9832. I created a couple of toolpaths, so I prepared another PPF to continue. Let's open the other PPF. You will see I already have the toolpaths, basic face mill, roughing toolpath. So 230 was the first probe, same cycle, and then a couple of extra toolpaths. And the end, the tool selection again. Let's make visible only the inspection and the solid feature, and then what other features we have. Circle, basically hover over on the surface and then select the cylinder. Just do 3, 4 and then 5 circle features and then arc feature. So you define the first hit and the second hit, and it will automatically generate between the two hits the inspection feature. Remember, Renishaw Inspection Plus on this Siemens controller support only 3 touches on arc measurement. So I'm going to do another arc on the side. Up, wrong click. Do it again. So one, another, and double click on the screen or on the feature window, and you are easy to edit the touches. Okay, change only to 3. Quick rectangle feature, and it's really easy. You just have to select 2 side and that it will generate the opposite one. Probe circle function. Remember, these cycles you can customize. You will see there is another tab. Do another circle. I make them hide. So remember, there is another tab, user parameters, what you can use for basically anything. You can generate another output. Those tokens are in the code wizard, so you can use for anything you want. This customer at the minute just wanted to use the top functions, so work update, dprint write function, and basically they are not using the rest because those are controlled by the Renishaw default variables. Let's change it to the association, so it will be the clearance from the Z0, not from the feature. Alright, let's create an edge feature. That's another popular feature. Sometimes you can use that as well for the beginning to update the work datum. Really up to you. I most like to do the 4 touches from the side, so it will be really in the center, but a couple of customers using only the corner touches and 1 touch on the top. So this machine is not support the plane, and it's not supporting the angled cycle. So again, if you have something similar, update your post-processor and then output an error to your customer about hello, remember your controller not supporting that probing cycle. Generate an NC code, cancel. And then open NCMO. So NCMO, this digital twin support the probing cycle, so the Renishaw macros in the memory folder. Let's double check the tool. I don't need the touch probe because that's already in the digital twin magazine. You can change the name if you wish. And then let's transfer everything to NCMO. I'm still using the 2021.0 version. And the reason I'm transferring everything to NCMO because I would like to show you the probing cycles are working. So it's reading the Renishaw cycles from the controller memory folder, and it's good to go. But let's look at it how it will simulate. So the DNM 450 containing only 1 tool, that's the probe, and the last one is basically the tools from the EDGECAM. Let's make it a bit more visible. So I didn't select the post-processor because I didn't select the NC code because in NCSIM I have to activate first the probe, and now I am able to select the generated NC code. Okay. Let's wait to load and decode the whole program. The red is, remember, on NCMO, it just shows you it's decoding the probing, and actually it can record the touch probes. So you can output from the virtual environment the printed values. Quick simulation to have the updated stock. You can see this is just a basic 3-axis kinematics running the Renishow macros, do the milling. Okay, jump in the end. Okay, and let's see those cycles. So 9800, this is the Renishow cycle. Yeah, because it's in the memory folder, I can open it and I can have a look on it. The parameters, you can see Siemens variables, what we are using to define the cycle, and then we have the protected movement. So just using the Alt-Gear movement, and then you can see this NCSimul is, because it using the Renishow macros, it simulated the double hit, and then it record the second hit. There is another good function. You can see the macros R23 equal 1, that's going to be the printed one, and the R19 equal 1, that's the update of the G54. So if I change in NCSimul the initialization, basically I have the G54 on the wrong position. So you can see the difference soon on the screen. The z-axis is actually 1 millimeter above the surface. So you can see that now. Let's use the arrows. It's position the tool there. First hit, second hit, and once it positioned back, hop, the z-axis corrugated again. And because the R19 equal 1 outputted, that's basically the function updating the G54 on Siemens 828. And you can see 23 equal 1, that's generate the report. And because NCSimul has a functionality for write reprint, it generated this Renishow underscore report file into my memory output folder. And now concentrate on the inspection. I also have a prepared file, a PPF, basically the same 3D model, but the EDGECAM Grobe machine. So let's switch off the machine and let's make visible only the 3D solid model. Okay, I'm going to use the same features. So do first circle feature. Oh, and you can see it's created by default a 4-pointed feature. So let's change the default circular feature to, for example, 6 touches, and then create again. Now you can see on the screen there is 3 touch points appear. Good, and then do an arc feature again. Keep it with 6 touches. And then what we have on this prepared geometry, I copied the stock from the previous Doosan model. I created a roughing and the finishing 5-axis toolpath, and I selected the shape probe. Let's select the inspection cycle. You can define offsets, you can do calibrations, and then with a big rectangle window you are able to select all features in one hit. Then go to tool change. You can do a simulation here, or you can do a simulation in NCMO. So again, full collision check. You can use EDGECAM to do collision checks and simulation, and of course it does check the axis over travel. Let's generate an NC code. So it's using my macros. Previous post-processor used the RaniShow macros from the controller, but this one using the hex move and hex write macros. Okay, NC simul prepared again. Let's select the NC code. Probe activation already selected, and then we have the probe calculation. I'm going to quickly run the simulation through to have the stock updated for the last couple of touches, and you can see the crop digital twin does the same movement what EDGECAM did. And then we have the EDGECAM inspection cycles running through. And because it contains a hex write function, it's create the result file from the virtual environment into the EDGECAM result folder. Let's select the result file. And then if you select the result file from the controller, it generates the report. So basically that's the main difference. EDGECAM does the calculation. And now let's talk about the EDGECAM post-processor customization and of course a couple of extra macros you might have to install on the controller. Let's start with the simple do someone. So this basic Siemens controller, what you have to do, update the template and then configure or add the inspection probing cycles. Once you have the probing cycles, then you will have this extra dedicated code constructor area with a probe cycle, probe point, probe circle, probe arc, probe plane. You just have to basically open them and then use the tokens to set up your machine to probing cycle. The tokens are there, so these tokens, each token represent one of the field boxes inside the cycle in EDGECAM. And of course don't forget to concentrate on the format table and then make sure the format output of your inspection tokens are the same what you need on a controller. So probing is simple as it is, you just have to take care about the probing code constructors. Once you're looking for the inspection, let's look at this group one. So if you add inspection code constructors to your post-processors, you also have a couple of extra code constructor area, like how to define the probe linear movement, the rapid touch movement, how to start the inspection, how to finish the inspection, and if you select inspection cycle, you can also able to use the inspection core tool change. Let's see what's inside, for example, in the inspection start. On the inspection start, what you will need to have inside your result file, you need the year, month, a day, hour, and a minute. So basically in the first line with the 1014, I define when the cycle used, and then I basically start the cycle with the cycle ID 1 and the cycle ID 2. Once I have that, I position. As I mentioned, you have two options for positioning. You can use the installed macros. For example, in the previous Doosan one, I used the Renshaw position macro, a protected movement, but on this one I'm using the hex movement mine basic macros. So I have to copy, in this case, 3 macros. One is the hex move, basically containing the X, Y, Z and the feed movement. I have in the probe rapid and also in the probe touch movement, where I using the hex probe subprogram installed in the controller, and it will also use a hex write function. So once I touch a surface, it output the measured X, Y, and Z. If you're familiar with Siemens, you can also recognize, these parameters are from the Siemens parameter. So basically, what you have to define: a rapid movement, a linear movement, how to define the touch. And if you define these 3 simple code constructor, then basically you can move your 3D touch probe without any problem. Don't forget to start the inspection and also finish the inspection. That's it. That's it basically. Well, I think you have an extra thing you need in the core tool change. Don't forget to activate your probe. So I'm using the Renshaw, so the installed macro, to activate the probe and also orientate the probe. So I always touch with the same surface. Let's look at those. Oh, just one more thing. In the Doosan machine, I also did a choice about on the probe rapid. The customer can choose they want to use the Renshaw protected movement or use my macro. Doesn't really matter, both working, depends on who runs the machine. Let's see the couple of macros on the controller. So I have 3 macros. One is for hex move, measure movement, basically G1 movement, simple Siemens macro. Hex probe is going to touch the surface, a couple of touches, do I have a contact or no, and then it gives you an error and the machine stop. And also on the hex write function, it's basically you are able to delete the file and then start a fresh new file for the result. And that's it. Basically, you have to know how to control the probe when it's switched on and how to write into a file the touched movement. Okay. And now let's go back to the presentation. I prepared an extra slide with a couple of questions, and I hope these questions will help you to understand what is the customer need. Is it a probing or inspection? If the customer doing an offline programming for mass production and they would like to simulate or working with tight tolerances, probing cycle could be really beneficial for them. If it's a new customer, then you can ask them, are they programming probing cycles on the machine? Or if it's an existing customer but buying a new post processor, you can ask them, is the machine arriving with already installed probing cycles? If yes, probing license could be a best choice to start with. For the inspection, if they are working with heavy rubs, the part can deform on the machine, or they just would like to do a first time right expensive material production proving, then on that case the inspection could be beneficial for them. And now let's hand it over back to Miguel. Thank you.